Bismillahirrahmanirrahim. Assalamualaikum and hi. My name is Nahidaya binti Abdullah. My case number is TD190023. Okay, so for the introduction, numerical method is a mathematics courses for engineers and scientists that aim to identify approximate answer to problems in science and engineering. It covers the theory and use of numerical algorithm that may use to find approximate solutions to issues like determining definite integrals or solutions of nonlinear ordinary differential equations, among other things. Numerical methods deal with a study of algorithms or approaches that involve numerical approximation to solve problems in mathematics and science. All of the issues that has been met in mathematical analysis can be solved by using basic operations like addition, multiplication, and division. The first objective of this project is to solve an engineering problem and propose appropriate solutions based on the knowledge of numerical method with error analysis. And the second one is to apply appropriate numerical methods using mathematical software in the project. And the last and but not least, to independently proceeds engage lifelong learning in a guided project.
My name is Amira binti Omar and I will explain about the real-world problems regarding Newton-Raphson method. The example of real-world problem regarding Newton-Raphson method is analysis of the water flow in water distribution networks. The cost-head-loss ratio question method was developed for optimal design of water distribution network. This method can be used to optimize the design and expansion of single source branch or loop networks with pump source nodes, as well as multi-source branch or loop networks. Water distribution network can be designed efficiently using cost-head-loss ratio technique. Moreover, this method is straightforward and may be used to create new networks as well as strengthen and expand existing nodes. This can be utilized to create multi-sources networks with pump source nodes and can be used for both branching and looping networks. Next, the real-world problem is bisection method, which is a skydiver speeds downwards when falling, gaining speed with each second. Increased air resistance is associated with increased speed. The force of gravity is encountered by the force of air resistance. The quantity of air resistance increases as the skydiver falls faster and faster until it reaches the magnitude of gravity's force. A balance of forces is achieved when the force of air resistance equals to the force of gravity, and the skydiver no longer accelerates. The skydiver is said to have reached the maximum speed. A downward falling object would slow down if it were subjected to an upward net pull. As a result, the skydiver slows down as the skydiver's speed lowers. The quantity of air resistance reduces as well until the skydiver reaches terminal velocity once more. Thus, by using bisection method, the drag coefficient of the skydivers can be obtained.
Okay, the first application that related to numerical methods in real life is an application of cuboid span and piecewise interpolation. It is a formula that was applied to compute heat transfer across the thermocline depth of tubules in a certain study area. Interpolation is a way of creating new data points with a range of a discrete set of non-data points in the mathematical branch of numerical methods. In simple terms, interpolation is a guessing at what occurs between two known values. Next, the temperature differential between each layer of the lake is determined by the thermal stratification of the lakes. However, using cubic spline interpolation and piecewise cubic interpolation, the values of the intervals between the thermocline depth, the temperatures of these intervals, and the heat flow will be employed to generate equation. And then to evaluate which methodology that has the lowest percentage error, the results produced using cubic spline interpolation and piecewise cubic interpolation will be compared. Okay, we go for next application. And for earthquake engineers, the second method is one of the analytical procedures that are available for estimating earthquake performance of buildings. The second method is used to create a linear dynamic analysis model with the ability to impact the structure's behavior in non-linear ranges. The second method may use to huge complex structures in a way that maintains behavior aspects that are typically lost during modeling. If needed, higher mode and torsional response might be collected. Because roof displacements are often dominated by first mode response, even in high-rise buildings with strong higher mode response, this assumption is commonly acknowledged as acceptable for obtaining realistic estimates of roof displacement.
Hi, my name is Rizana Amira and I'm going to take over for the part of the real-world problems using Newton divided difference. So, one real-world example of how this method might be applied is to verify a census of the Malaysian population that was taken every 5 years from the years 1955 to 2015 in order to find the population in the year 1963 from the polynomial that interpolates the data from the years 1955 to 2015. And so, the purpose of this study is to determine the accuracy of the data and discrepancy between the actual and the calculated data. So, due to the uniqueness of interpolation polynomials, this approach is similar to Lagrange method for finding an interpolation polynomial in that it returns the same interpolation polynomial each time it is used. So, why is this study is needed? Well, most countries, including Malaysia, conduct population census on a regular basis in order to determine the population growth of their respective countries at a given point in time. So this will assist with the research businesses and financial planning, among other things. So based on the real-world examples provided, the team agreed to vote to conduct a more in-depth investigation into Newton divided difference. The case study was to validate the Malaysian population census that was taken every 5 years from the years 1955 to 2015 in order to discover population of the year 1963 from a polynomial that interpolated the data from the years 1955 to 2015. So furthermore, the goal of this study is to determine the accuracy of the data as well as the disparity between the actual and calculated data. So, as we have learned in numerical method, we do the calculation by utilizing the first divided difference, the second divided difference, and so on. A table known as the divided difference table is created as shown on the figure. So, we have to do the processes until we get the full table of each order of the divided difference. And from the table data, the interpolating polynomial resulting from the divided difference method takes the form as such shown in the slide. So, we will perform the divided difference method to find the interpolating polynomial of this point and approximate by the polynomial at F1963 by substituting x on 1963 to find the population on the 1963. So the answer will be, and then to validate the data, we use C++ using the coding shown on the slide. Okay, next, as in the comparison, the value is merely the same as in calculation. The Newton divided difference can be used to find the interpolating data. True, there is a small gap between the real data and the calculation, which is understandable given that it is involve a human population which we can't really control. So because even with a good tools, we cannot predict the exact data. And with that, I say my thank you.
In conclusion, at the end of this assignment, every group members are able to obtain more knowledge about how practical numerical method is in every way of daily life. Every mathematical problem has their own ways of solving, and Newton divided difference is one of such approaches to solve the problem. The chosen issue of nation population of census is an example of how numerical method can be used to discover the population of the year 1963 from a polynomial that interpolated the data. In this task, Microsoft software such as Freeman and Excel are used to validate the answer that was calculated manually. The numerical method is a subset of modern computation that finds use in engineering, biology, and even the arts. It has the ability to predict what is going to happen in this world.